In this particular tutorial, we're going to talk about the different ways in which we can symbolize data. I ran a previous example where I ran a spatial join between counties and tornadoes to count the number of occurrences of tornadoes within a particular county. So I created a brand new feature class from two existing feature classes based on a spatial relationship, which in this case was containment. Now I want to symbolize those. And you can see that I ran it right here. And I can click on this brand new feature class and I can click on Symbology. Now I have single symbols, unique values for nominal data, and I have graduated colors. So under these graduated colors, I have different fields here. In the previous example, I created a field for the number of tornadoes, the number of fatalities, and the number of injuries. And we created these based on the sum, which is what happens when we add everything up. So for this particular count here, we can just look at the total number of tornadoes for each of these, and you can see their value in this particular legend, but before we go and actually make the map. And so you can see these values here. You can see where they're higher and where they're lower over towards the coastal plain. We have a higher number of tornadoes. Over towards the mountains, we have much less. But it's under the symbology. Now we have a number of other ways that we can symbolize our data here. And if I right mouse click and click on Open Attribute Table, you can see this fairly simple feature class that I created as a result of the spatial join. Now I have other types of feature classes as well here, and this is for counties. If I open the attribute table, you can see what I have. I have some census data, and this is what we call SF1 data for 2010, 2013. I have different race, ethnicity, and then age demographics here. And we call it SF1 because this is called short form 1 because it's data collected from about everyone for the census. Average household size. We have other data such as income or education attainment or commuting time, which is sampled, which is collected by only a certain number, for only a certain number of people here. So you can see, well, I want to calculate one of these. I want to visualize one of these, something like median age. And I can do the same exact thing here. I can go to Symbology, graduated colors, and you can see I've cut and pasted this a number of different times here. So under median age, I can pick the values, and I'm going to pick my color scheme here, and I can pick my method. And I like quantile because it makes sure that it ensures that each county appears the same number of times. I have 5 classes, and so you can see what a 5-class quantile looks like for median age. So you can see where they're older and where they're younger. Now another thing that we can do here, and I've already set this up here, is a pie chart. And what I did was right mouse click and I copied and pasted this. So essentially what we're looking at are 2 different attributes on top of each other at the same time. And so this thing here is symbology, and I added a chart here. And so I looked at the different race cohorts within these particular data. The one challenge with mapping is that it's very difficult to visualize more and more attributes within the confines of one map. So it gets very, very busy. And so I do have 2 attributes here. I have median age, which you can see as a core pleth map where we have the polygons. And then on top of that is that we've got a pie chart here where we have a pie chart based on the different races provided by the census here. And a whole circle is 100%. So you can see where there's a higher percentage of white residents as opposed to other races here that are collected by the census. And so under fields, under this drop down, I can go to different fields and add these. And I can also put the colors in these as well. And so this is under symbology and charts. I have proportional symbols, I have graduated symbols, I have a number of different symbols here that we can show these on top of each other. So graduated symbols will show bigger dots versus smaller dots for a particular phenomena, whether it's point or polygon phenomena in this particular case. So we have really neat ways to visualize and highlight our different types of data. Now the other thing that I want to talk about here are showing histograms and scatter plots. These are a couple of things that I like to do. And so under my symbology, I'm going to go back to single symbol. And so under these attributes, I can right mouse click and I can click on Create Charts. And I can create a brand new histogram chart which shows the values versus the frequencies. And so under these values here, if I wanted to map POP 2013, these are all the different settings that I have here. It's got the mean, the median that I can check, and the standard deviation. Now, you can see this is skewed here, and we've talked about before that the value of having normalized data versus non-normalized data, because you can see here there's a lot of counties here that have between 4,300 and 99,639, so you can see a lot of values here. I'm going to go back to this median age because I know that it's normalized data. So you can see median age, and you can see it's skewed. I believe this is called skewed left. But you can see the mean, the median, and the standard deviation all on the same chart right here. And I can pick a number of different things. Say, average household size, which is also going to be normalized. I like looking at these normalized data a little bit more because it gives me it's not going to be skewed as opposed to raw data. So I've got my mean and my median highlighted on this, and you can see this chart. I have the min, the max. So if I subtract the two, I'm going to get something called the range. We've talked about this before as a measure of descriptive metrics. I have the sum, number of nulls. Skewness tells me how skewed this map, this particular histogram is. And then I have kurtosis essentially tells me how steep this histogram is. And I can change the number of bins. So I can increase the number of bins up to 25, or decrease it down to 8 or 4 or whatever. I think 9's a really good number here. Now, the other thing that we can do here, we can look at the properties. Okay, and I can label axes and look at these different guides and change the numbers and all that other good stuff here. Okay, so I can, type in median age and median age, and then type in something like frequency. Okay. Now, the other neat thing that I can do is I can export this. And so now I can export this and give it a name here. So I can export this and insert it into, say, a PowerPoint or a Word document. So I can call this Tim's histogram.jpg. And there it is. And so now if I'm working with a PowerPoint presentation, I can insert a picture from this particular device. And I can find this particular picture right here. And then here it is. So now I've got this histogram, and I can change it and edit it the way that it looks and feels here. But this is a really powerful tool, and in addition, you will be expected to do something like this for your homework. But you can see this chart here. If I go back to it, this chart should still be alive here in my table of contents here. So obviously you can't see it on a map because it's integrating some attribute data, which isn't even spatial in nature. It can be mapped spatially like we showed before. So the last thing that we have here is something that I like called scatter plot. Scatter plot looks for two relationships between each other. See if one can maybe explain those. And as we get later in our geostats class, we'll explain linear relationships and how to quantitatively tell if one can explain it with some statistical significance. What we're going to do here is the same exact thing. I'm going to right mouse click, and when I click on this is called a context menu. So you can see there's about 16 or 20 different elements that I can click on here. And we've got labeling, joins and relates that I've alluded to before, but I'm going to click on chart. I'm going to look at scatter plot. And so now I've got x-axis. So I can basically see if age explains household size or average family size. Okay, and you can see as the age gets higher, the household size gets smaller and smaller. And that kind of makes sense here. But you can see we've got some neat things here. We've got a line of best fit. We have something called an R squared. This R squared, and we'll explain this later, tells me how well that y is explained by x. Okay, so if I know that the age is 46, I can explain or I can predict the age with 50% accuracy, or I can say that 50% of the average family size is explained by age, the other 50% is explained by something else. But we can do the same exact thing here. So you can see this graph, and this is what we call a negative correlation here, but it's pretty neat here where that you can see, well, I do have counties here where the median age is really low, but the household size is also extremely low. And I think this is Watauga County, I believe. So if it is, that's probably a college town where there are a lot of young people, but not that many families. But the same exact thing that I can do here, but is that I can export this map as well. So in conclusion, I got a couple of neat things that we talked about with how to visualize data. We can change the symbology. We can show it as bar graphs, circle charts, or circle graphs. We can also do histograms, which you'll be expected to do for this particular class. And we can also explore linear relationships. We'll look at things called OLS, ordinary least squares, where we're looking at more than one variable to explain those, which get very difficult to visualize. But using one variable to explain the other, you can see right here that can be exported and highlighted onto a Word document or PowerPoint presentation.